this video, we are going to continue talking about ratios, proportions, and scales and their use in business. This one in particular is going to focus on scales. Scales and rescaling are used frequently in business whenever large things need to be presented in small formats. Presented or just contained in small formats. Scales quantify the relationship between the larger version and the smaller. If you are designing and selling something like a 3-ton Ford F-150 Lightning pickup truck, along the way there will be scale drawings which recreate the truck in miniature, digital renderings of the truck with various equipment options, and three-dimensional models of various sizes and complexity. These kinds of drawn or digital or physical models of the truck would exist in scale with the truck itself. A scale captures the relationship between the dimensions of the truck itself and the dimensions of the smaller version. So of course, not everything uses scale. If you're just presenting a slide with a picture of an F-150 on it, it doesn't really matter if it's to scale necessarily, if it's just an accent to a slide. But if it's a design document or a specification document or anything that requires certainty and exact measurements, then you would need to provide a scale. For example, suppose you needed a 10-inch long scale model of the F-150 Lightning. The F-150 Lightning itself is 231.7 inches long. What is the scale for the model if the model is 10 inches long? The scale is the ratio of the two lengths. So 10 inches to 231.7 inches. And you could just leave it at that, 10:231.7. However, it is easier to use a scale when one of the numbers is 1, because then you have 1 of this and that equals this much of that. So they are often divided through to produce that outcome. In this case, dividing the numbers in the scale by 10 gives you 10 divided by 10 on the left side, which equals 1, and 231.7 divided by 10 on the right-hand side. Dividing by 10 moves the decimal point once to the left, so you get 23.17. Given that the original dimensions, 10 inches and 231.7 inches, were both in inches, dividing through by 10 is not going to change anything about the units. It's just a factor. So you're left with a 1 inch to 23.17 inch ratio. This is a scale. This ratio is a scale. So a scale is a type of ratio. It tells you that every inch measurement on the model corresponds to a 23.17 inch measurement on the truck. Does it have to be in inches? No, certainly not. Scales can be of mixed measurements. We could do this scale in inches and feet. We could say it's 1 inch to 1.93 feet by converting the 23.17 inches into feet. 23.17 inches is 1.93 feet. Always check the units of measure when you're using these kinds of scales in order to avoid unforced errors, like thinking that you have inches to inches when you actually have inches to feet, or thinking you have minutes to minutes when actually you have minutes to hours. One thing that it is helpful to notice is that a scale is just a special type of a ratio. So a scale is just a ratio. That means we can use cross multiplication to solve when using scales. Let's take a look at example 9.7. An architect provided blueprints to a client showing a 1:20 scale drawing of the interior of her new business. On the blueprint, the ceilings are 9 inches high. How many feet high will her ceilings be? When a scale is presented like this one, 1:20 scale without any units, it's implying that the parts are in the same units. So you could do 1 foot to 20 feet, or you could do 1 inch to 20 inches, or 1 meter to 20 meters. In this case, what I'm going to do is treat it as inches to inches. I'm going to find the answer, how high these ceilings are in real life in inches, and then I'm going to convert them into feet. So what is our unknown? X. Our unknown is the height of the ceiling in real life. And the ratio is giving us a blueprint to life scale. It's saying what you see on this blueprint in life is going to be 20 times the size. So on the blueprint, what shows as 1 inch in real life is going to show as 20 inches. That's going to be our ratio on the left-hand side. We're going to set that equal to, on the blueprint, the ceilings are 9 inches. In real life, what are they? We don't know. That's X. So you see an equivalent way that I could have done this, what this arrow means is equivalent, is to reverse the ratio and say in real life we would get 20 for every 1 on the blueprint. So in real life we're going to get how high ceilings for 9 inches. These two math problems will turn out exactly the same. But the deal is you have to keep the ratios in the same order on both sides. So this 1 is blueprint measure, just like the 9 is a blueprint measure. The 20 is the real life measure, just as this X is going to be the real life measure. Blueprint measures are on the top on both sides. The real life measures are on the bottom of both sides, and vice versa in our equivalent equation. I'm going to do this one. So X times 1, cross multiplying, and you get X. 20 times 9, cross multiplying, and you get 180. So X equals 180. Now this is going to be inches, and we're asked how many feet high will her ceiling be. We can use our idea from the units section about unit conversions using ratios. So we have 180 inches, and I'm going to set up a conversion factor that equals 1 when you consider the units. The conversion factor is going to have 1 foot on top because I want feet at the end of this, and 1 foot is equivalent to 12 inches. In terms of converting inches to feet, 12 inches is 1 foot. 180 inches is on what we would call the top. It's not a fraction, but that implies it's over 1. It cancels with the inches on the bottom of the fraction that you're multiplying it by, leaving feet as your unit. And you get that this woman is going to have 15-foot ceilings. If the conversion interests you or confuses you, please return to the units section because I think it will help. Scales are not always physical measurements. They don't always have units of measure on them. They often do, but not always. Scaling up and down can happen for other types of quantities as well. Let's take a look at example 9.8. Example 9.8 says a small business owner provided catering services. Her typical orders have her catering 4 events per week, for which she needs to order 25 pounds of ingredients total. Next week, she anticipates being very busy because she has 7 meals to cater. How many pounds of ingredients will she need to order? What is her scale of events to ingredients? So we're actually going to start with the second question. What is her scale of events to ingredients? What we're shown in this question is that typically her catering is 4 events per week for which she needs to order 25 pounds of ingredients total. So her scale of events to ingredients is 4 events to 25 pounds. If we divide that through so that we can get a 1 for one of these, I'm going to divide it through by 4. So divide both sides by 4. And you get for each event, she needs 6 1/4 pounds of ingredients. Next week, she anticipates being very busy because she has 7 events to cater. How many pounds of ingredients will she need to order? By the way, the ratio 4 to 25, 4 events to 25 pounds is the same mathematically. It's mathematically equivalent to 1 event to 6.25 pounds. They only differ by this factor of 1/4 or by a factor of 4. You can use either of those ratios to set up the cross multiplication. You'll get the same answer. We define our unknown X, and X is pounds of ingredients. Having defined our unknown, let's go ahead and set up our ratios, set up our cross multiplication. Let's see, I'm going to use the 1 to 6.25. So she needs 6.25 pounds of ingredients for 1 event, and we're going to set that equal to X pounds of ingredients for 7 events. You see, converting it to a 1 to 6.25 pound ratio is saving us a step in the algebra that we're doing to solve for X. Because since we have 1 event in the denominator on the left-hand side, that's 1 times X, so we get X cross multiplying this way. And cross multiplying this way, we get 6.25 times 7. What that equals is 43.75 pounds. So the events actually cancel out, and you're left with pounds. So for 7 events, she needs 43.75 pounds of ingredients.